In this video, we briefly introduced the theoretic study of antenna scattering problems based on characteristic modes and its application in reducing antenna scattering. The relevant work can be found in IEEE Transactions on Antennas and Propagation. Low scattering antennas are urgently needed for low observable platforms. As a special scatterer, the scattering mechanism of an antenna is complex, which results in the difficult design of low scattering antennas. The reported antenna scattering theories classify the scattering field of antenna into structure mode scattering field and antenna mode scattering field. However, the composition of the two fields and the relationship between the two fields are unclear. In this work, a specific set of modal electric fields, which of an antenna loaded with a short circuit, is used to express the structure mode and antenna mode scattering fields of the antenna with arbitrary loads using characteristic modes. From the view of physical structure, the contribution of each characteristic mode to the structure mode and antenna mode scattering fields with arbitrary loads can be clearly analyzed, which efficiently guides the antenna scattering reduction under the incident plane waves with arbitrary propagation direction and polarization. A typical microstrip antenna is given as an example to validate the proposed ASTCM. The radar cross-section of the microstrip antenna calculated by ASTCM agrees well with the results simulated by commercial simulation software. In order to give a guidance to the antenna RCS reduction, the design procedure based on the ASTCM is summarized. The design process of a low in-band RCS microstrip antenna is shown. A pair of slots and patches are utilized to decrease the structure mode scattering field of the antenna excited by X and Y polarized normally incident plane waves, respectively. Compared with the reference antenna, the proposed antenna 2 achieves notable RCS reduction in the operation band while its radiation performance is well preserved. More details of the work can be found in the reference. Thank you for your attention.